Hi. Okay. Continuing on, we are now going to look up what is called the C matrix and how to interpret the local shape change. The basic idea is that F tells you what happens to the individual line elements by themselves and doesn't compare line elements. So if I want to look at shape change, somehow I want to know how much length change has happened, whether it's become larger or smaller, whether the angles between them has changed and all this stuff. So that's where C matrix comes. The diagonal terms of the C matrix gives you the square of the stretch ratios. And the off diagonal terms give you information about the cosine of the included angle between lines. So this is the meaning. So if you can see that the off diagonal terms don't directly give you the cosine, they give you some information about it. You have to extract the cosine from that. I will show you how to do that with this particular calculation. Okay. So how to find out length and angle ratios by computing C. So we remember this previous problem where we showed that the original dotted lines became the solid lines that you can see in the picture. So the x-axis line element becomes the red arrow, the y-axis line elements become the green arrow, and the z-axis line element becomes the blue arrow. And you can see that what used to be perpendicular now look at some funny angle, and we want to be able to compute all these angles. So what we know is the F matrix, and for us the F matrix at the point of in question was 1.4. It's not -4, it's minus 0.4, 0, minus 0.6, 1.3, 0. That's the second row. Third row is minus 0.5940, 0, 0.8020. Okay, very good. So what we want is to find the stretch ratio and the angles between the lines. What do we mean by stretch ratios? It means what's the final length divided by original length. So that's what we want. That's what is called the stretch ratio, so that I know how much it has been stretched or squished. Okay. What we mean is that the stretch ratios multiplied by the scale factors will give you the final length. Can you see? S1 dx is the final length of the red arrow. S2 dy, that's the stretch ratio S1, S2, S3 are the ones that we have to compute. Will give you the final length of the green arrow, and S3dz will give you the final length of the blue arrow. And then theta 1, 2 will tell you what's the angle between the arrows. You know, theta 1, 2, theta 1, 3, theta 2, 3. You can read off from the subscript. Okay, so how do we find it? First thing to do is to compute F transpose F. So off you go. You compute F transpose F, and that's pretty easy. Take the transpose and compute. You will get first row is 2.6728 minus 1.34 minus 0.4764. Second row is minus 1.34, 1.85, 0. Third row is minus 4764, 0, 0.6432. Notice that the matrix is symmetric because of the fact that we're doing F transpose F. This contains all information about shape change. So C is what you look at for shape change. So the stretches are the square roots of the diagonal. So that's easy. If you do S1, it is square root of 2.6728, which is 1.6349. So roughly speaking, the x-axis got stretched by a factor of 60%, about 60%. S2 is square root of 1.85, and that is 1.3601. So the y-axis, which is the green arrow, got stretched by a factor of 36. And you can see that, no? One is stretched by a factor of 60%, the other one is by about 36%. And then S3 is square root of 0.6432, which is 0.8020. That means that S3, the blue arrow got shrunk a little bit. Okay, so that's as far as length changes go. How about angle changes? So what we do is we compute the angles from theta ij is cos inverse Cij divided by Sij. So you look at the off diagonal terms divided by the corresponding terms in the corresponding stretches, and you'll get the cosine of the angle. What I mean by that is, if I want to find out the angle between the red and green arrows, that is theta 1, 2, cos inverse C12 divided by S1, S2, which is cos inverse minus 1.34 divided by 1.6349, should not be 79, should be 49, 1.3601. It's about 2.2 radians, 127 degrees. Can you see it got opened out? Similarly, you can compute the angle between the x and z axis as 113 degrees, and the angle between the y and z axis as 90 degrees. So the y and z axis are still perpendicular. Doesn't seem that way in the figure, because of the perspective, but it is perpendicular. Okay, that's how it works. Okay, thank you.